And so the thing I want to talk about a little bit is like I think everyone across our industries is figuring out how to work with AI. Like how do we use AI to make ourselves more productive? And a fair amount of that conversation, I think, right now, especially because agentic coding is sort of where AI has seems to have found its niche, where it's generating value and people are willing to pay enormous amounts of money for it. Um, but a lot of our job when it comes to web performance is more analytical than it really is about coding. Like often the fix is just a couple of lines, right? We're just, we spend like a day digging into something, digging through profiles, and then eventually we figure out, oh, shoo, I should remove this API call, or I can short circuit this thing, right? And so generally speaking, how to do that through code inspection when you're using something like Claude Code or Codex, that's pretty obvious, right? You start feeding a code, or you're like, try and figure out how to make it faster. Now, the reality for those of us that have actually tried this is that models like Claude and Codex right now aren't actually that good at this. And that's not surprising, right? Because if I know that my site is slow and I just go and read through all the code of my website, I'm also not likely to figure out why it's slow. And so, an obvious solution that you might want to look at is what would I do when I encounter that? And the reality is, I take a profile and I'd look at the profile and see what is slow. And then I kind of know what to look at to fix. And so that is what we also want to make possible for the AI. And so we have done that, or well, we have done that. Nazim has done that, right? And he has built like an amazing tool that basically is specifically designed as a command line tool. So for agentic command line driven tooling to interact with and to analyze profiles that come out of the Firefox profiler. And that should work for helping web developers find well, helping web developers get Claude to find the slowness in their websites and propose fixes. And so, and other AIs, right? Like it's not obviously you can feed it, you can use it with Codex or any AI that can agentically use the command line, right? And so let's see if that actually works. Nazim, go right ahead.
Yes, thank you, Bas. I think I can use this one actually. Because I need to use my
Used to use the rubbish
Yeah.
microphone, yeah.
Yes. Hi everyone. Thank you. Thanks, Bas. So yes, today I will be showing you the profiler or the Firefox profiler CLI. So we published it at npm, and you can find it here. It is called at Firefox DevTools Profiler CLI. And you can download it through npm like this, npm install-g, and then the name of the tool at latest, and you should be able to install it quickly. So let's do that. First, let's do it in here. So since I have it installed, yeah, since I have it installed, it just install it very quickly. And now that I have it, I have access to the profiler CLI. So I'm not going to get into the details of all the commands because ideally we don't have to know about those because Claude will or AI agents will handle it for us. The the one that we need to know is this, the guide, because Profiler CLI comes with this guide that teaches agents to how to use it basically. And so, but before, let's take a profile and then feed it to the Profiler CLI to see how it works. So I prepared a little demo from before. So like very old particle physics that that we prepared, and like you can see, I increased the particle counts, and now I can see that like it's a bit janky when I try to like interact with it. And I want to understand why. Like it's not as smooth as I would like it to be. So for that, I need to go to profiler.firefox.com, enable it if it's not enabled yet. So I go here and then click on enable. So now this is enabled. And I can do like start the profiler and then do some interactions. So I can see that it's very slow now. And I click again to capture a profile. Now that I have captured a profile, I can see a lot of like red bars over here. So it means jank. Um, I don't have to look at it anymore. I can just directly upload it. So I can click on upload and I get a short link with me. So now what I can do is to just feed it to the profiler CLI to let it figure it out. So let the agent figure it out. So I've already done that because it's gonna take a while. So I wanted to be quick here, but I can show you what I did. Hopefully it's readable for you. Is it? All right. So I said, I'm trying to understand why this particle physics demo is performing badly when there are so many particles. Is there a way to improve the code? Can you check the profile that I captured where I was hovering over the canvas? And I passed, this is the profile. So I passed the profile link. And I said, use the profiler CLI to debug it, execute profiler CLI guide first to understand how to use it. So this is what I said. Ideally, we could also use like Claude skills and other things, but I wanted to just make it simple. Just execute profiler CLI guide and handle the rest. And it did execute the profiler CLI guide and then started loading the profile and looking at the details and try to understand. So it saw, oh, massive CPU is in canvas fill. So let's explore this area. And then it said, oh, the dominant cost is canvas rendering context 2D.fill. And it wanted to annotate, so it wanted to look at the content of this function to see what's happening there. And then it figured it out. It says the dominant problem is the render, zone intersection observer dot render. And it says this is the line that we have, lots of fields. And this is because it's basically ON. Like we do this for every single particle, which is a lot. And then it found a second hotspot saying that trail rendering. So there are some more stuff happening. It says that like we have trail batches, so we can maybe batch this up, and then there are smaller fields. And it already recommended some fixes for me. So it said aggregate zone intensity, so we don't have to draw for every single particle, and then prune this, and then some more things. And I said, like, it asked me, want me to implement these? I said, yes, of course. So, and then it did implement those things for me. And you can see all these. And then it wanted to verify, and then the result was yes. And now, like, this is the second particle that it actually worked on, and you can see that it's very smooth as opposed to the previous one. So, yeah, this is how we use it to improve some performance of some websites. So thank you.
Thank you so much, Nazim. And I just want to say, because I came very poorly prepared today, I came in this morning and I was like, oh boy, I still have to prepare this talk that I have to do later. What am I going to do? What am I going to do? It's got to be something with AI. It has to be something with AI. And I think I spoke to Nazim around noon, probably. And I told him, like, we've never really done anything like this, but can you please do it for me? Because I got this talk I need to do. And it took, well, you were like, well, if this other talk I have to give, I can start working at a 3, right? And so he started working at a 3. He pretended like, oh, it takes a long time, but I think you were done at 3:45, and like the demo is basically ready at 4:30. So the speed at which you can do things this way and figure out these problems is just incredible. So first of all, thank you, Nazim, for helping me out, and thank you all for your attention.
Okay. Thank you.
That being said, thank you very much for that great demo.